Yeah, I'm Rick Lanman. I'm a physician scientist, retired about 5 years ago. I used to do oncology and genomics. Now I do historical ecology. That is, I research the historical flora and fauna of California and our region in particular. I live on Adobe Creek, which we're standing in right now, from El Camino Real to the bay. As you can see, it's a concrete trapezoidal culvert. This is to speed floodwater out. Unfortunately, it makes it impassable for steelhead to come up. Other rivers, like the Guadalupe River, the dams are far enough up that steelhead and Chinook salmon use those streams. And I'm very excited to watch over the last several decades the Chinook salmon population in the Guadalupe River watershed, which includes Los Gatos Creek, Guadalupe Creek, and Alamitos Creek, to watch the salmon population continue to rise. Every winter, December, January, we get fall-run Chinook salmon running up this system and spawning. For a long time, we were told these are just lost hatchery fish. They would raise Chinook salmon in Central Valley hatcheries. In the drought years in particular, they didn't have enough water for them to swim downstream, so they would take them in trucks and dump them in the bay. Those hatchery salmon don't know where they were born. They don't know where their natal stream is. So they just use whatever, they stray to whatever stream they could use. Genetic studies of our Guadalupe River watershed salmon show, in fact, that most of the salmon are hatchery fish, hatchery strays by genetics. But 2 of the 3 studies also showed that some were wild strays. One study showed some of the fish were Russian River genetics in the Guadalupe River. So they had strayed from the Russian River, which is supposed to be the southern limit for California coastal Chinook salmon. But here they are further south in the Guadalupe River. Another study showed that some of our Guadalupe River Chinook had lower Columbia River genetics. So Chinook salmon stray. Most of them go back to the stream where they were born, their natal stream, but some stray. And it's a good strategy evolutionarily, because your stream might dry up, there might be a wildfire, it might silt up, or some obstruction. So a small percentage use different streams. I was told these Chinook salmon can't be native, and all we could find in our research was a historical newspaper article from 1904 that said the boys would go out with spears after the winter storms and spear salmon and steelhead in the pools in urban San Jose, in the Guadalupe River, and probably Coyote Creek, but it wasn't clear. Now, it was important that they mentioned both steelhead and salmon, because a lot of people say, oh, they called them salmon, but they were just large steelhead. Well, they mentioned both. So this was intriguing. Kenneth Gobele, a PhD archaeologist, one of perhaps the foremost ichthyofaunal archaeologists, an archaeologist who specializes in fish remains, fish bones, basically, said, Rick, we have a lot of vertebrae from salmonids from the Mission Santa Clara right on the Guadalupe River. Just it used to be Mission Creek, a short tributary to the Guadalupe River main stem. They're very close, less than a mile away. We can't tell from the vertebrae whether these are large steelhead or medium or small Chinook salmon. This is circa 1800. We did an ancient DNA study of those bones. We published that study in 2021. We found 3 Chinook salmon, 3 different Chinook salmon, circa 1800, from the Mission Santa Clara bones that were there. So that was the first physical proof that Chinook salmon were historically native to the Guadalupe River watershed. More recently, Steve Holmes, Brian Allais, PhD, super helpful, and South Bay Clean Creeks Coalition started collecting spawned out adult carcasses, eye lenses, and ear bones, otoliths, for isotope studies. Let's talk about isotopes for a minute. What we wanted to find out was, were any of these salmon that we have coming back and spawning, and that reached about 600 Chinook salmon coming up the Guadalupe River last year, were any of them born there? Or were they just newly coming in from other streams, wild strays, or from hatchery strays? The first study, looking at the eye lenses, these eye lenses have lenses like tree rings. The innermost eye lens layer represents the environment in which they were born. And they have different sulfur 34 versus sulfur 32 isotopes. Turns out hatchery fish are fed fish meal collected by nets in the open ocean. The ocean has a much higher sulfur 34 isotope. Chinook that are born in rivers and streams don't have as much sulfur 34. They have more of the regular sulfur 32. So South Bay Clean Creeks collects literally hundreds of fish from the late 20 teens to now. Harvest the eye lenses from the spawned out adults. We send them to UC Davis to the radioisotope laboratory. And the first series of, I think, 3 years, we find 10 that were born in the wild by the sulfur isotope. The rest were born in hatcheries. So now we selected down those 10 and we turn to the otolith. And now we're going to look not at sulfur isotopes, but strontium isotopes. Strontium is right below calcium in the periodic table. Otolith is basically a little bone rich in calcium. Well, strontium also gets in there. Each river or stream has a different strontium isotope ratio. These have been mapped out for the rivers of the Central Valley by UC Davis. And you can tell from the innermost ear bone layer, from that strontium isotope, does it match the strontium isotope of the water from that river? All the fish in that river, they'll live in that river, their first year, their innermost otolith has that strontium ratio. The water itself has that strontium ratio. So South Bay Clean Creeks collected water specimens from 10 different reaches in the Guadalupe watershed system. And we established with UC Davis the strontium isotope signature of the Guadalupe River watershed. It's a little bit complicated because we have a little water mixing in that gets shipped in from San Luis Reservoir and others, but pretty clear and pretty different from all of the Central Valley rivers except the Tuolumne, where it overlaps. Of the 10 fish from the eye lenses that we knew were wild born, one of them was born in the Guadalupe River by the strontium isotope ratio. There's 2 or 3 others where we couldn't tell if it was Tuolumne or Guad. But this is the first physical proof. We haven't published it yet. And I think we should probably collect more specimens to see if the number is going to increase over time. But it's the first physical evidence. We had a Chinook salmon born in San Jose, returning to San Jose. They spend about 3 years in the ocean, sometimes 4, 5, 6 years. And then they come back to spawn. And of course, they die after they spawn. Really exciting data. And working with Malte Wilmuth, who was at UC Davis and UC Santa Cruz and is now at the Fish Institute in Norway, and some of the UC Davis team and Kramer Fish Sciences on this project. But I really want to thank the South Bay Clean Creeks Coalition for their work and all this hard work to collect these priceless specimens. No one has done this before. They've done it on Punta Creek and Central Valley, but nobody's done this in Bay Area tributaries. 3 Bay Area tributaries have Chinook runs: Guadalupe River watershed, Napa River watershed, and Walnut Creek. What do those 3 streams or rivers have in common? They have in common a long lower reach that's intertidal. Our salmon don't spend a year in fresh water. They're adapted to go back out in May because we get such a droughty, hot, dry summer. I think they spend time in these lower reaches that are intertidal to get big before they go out to the open ocean, where size matters. If you're not big and you're a little baby salmon smolt and you go to the open ocean, you're going to get eaten. The greatest predictor of survival in the ocean is how big the smolt is when he or she leaves. So I think these systems have long intertidal reaches, is enabling the Chinook salmon population now to come back. I think we have some wild salmon here, swamped by all these hatchery fish. But I don't care. I don't care if they're hatchery fish or wild. I just want our salmon back.